Hey everybody, in this video we're going to look at some advanced memory management for Assistance API to manage our messages within a thread. As you may already know, Assistance API works with threads, and threads includes many messages, and this thread is managed automatically by OpenAI in the background. And when the messages are in this thread, then you cannot delete the messages. So therefore, you cannot really implement token limiting strategies. We might think, well, why don't we replicate a thread with some of the messages? But that's not possible either because you're only allowed to create a user message. So therefore, you cannot replicate the assistant messages. But I came up with a few strategies to alleviate this. But the problem here is as we deal with messages, let's say these messages are coming in, the first message came in, the second message, and as these messages accumulate, even though this thread and its messages are managed in the background, it will eventually accumulate up to 128K context limit, and then your each call will become very expensive. So we're going to solve this problem. We will solve this in 3 different files, from basic to more advanced, and all these files will be available at Patreon. Link will be in the description. Our first method is going to be take the messages and accept the messages, have a memory limit based on max words, and as soon as the message limit is filled and our messages are going beyond it, we will have an ingenious strategy to remove these messages and create a new thread each time this happens. So therefore, we will actually keep a token limit on our thread based on max words. So this will be the basic implementation. The second method is going to be more advanced. Again, we are going to have the memory limit with max words, but once this quota gets filled up and then we go beyond it, instead of just deleting it, we will start summarizing these messages. However, at some point when we go beyond max words, we will not include the summary in our max words counts. So therefore, we will actually continually summarize after each call, which may or may not be desirable for your use case. That's why I came up with another method as well, which is a full summarization method. We will again have a max word count, and as soon as we reach its limits, we will always summarize. So that's why we will actually never lose the messages, and we won't be summarizing every time we go beyond our max word token limit, because we are not summarizing part of it and keeping the rest of the conversation as normal, but we will be summarizing the entire conversation. So let's take a deep dive into the code now. The first file includes some useful assistance code snippets, which you can use. This is just some code snippets for how to. The second file actually includes an entire running functional chat loop. When you run this, you can enter your messages and you get responses. Just like a regular chat loop, but with the Assistance API in a single thread. For this, I'm retrieving an assistant that I've already created, but if not, you can actually create one as well, or change this assistant ID with yours. You can get your assistant IDs by clicking on Edit and finding the assistant ID right here from the playground. So if you leave this assistant ID empty, then this try will fail and you will create a new assistant. Then we create a thread and we enter a loop. We take in user messages. And after that, we keep adding to these messages. We create a run, and we wait on that run with this function. And when the run has been completed, we retrieve the messages using the order and after. So because we want to retrieve after our last message, so therefore we are only printing the assistant messages. These first 2 files will be available at my Patreon at the $9 level. Link will be in the description. Now let's move on to the basic memory management. So for this one, we are setting a max words to 500, and at some stage we are going to enter into memory consolidation phase. So how are we going to approach this is that all of these messages is going to have 2 roles, right? One assistant or one user. We are simplifying. So we want to, once the messages are being entered, and once we have reached our limit, max word count, then we want to grab everything that is beyond it, remove those messages, and since we cannot create assistant user role in threads, we will actually reformulate this into a secondary memory structure, and then we will append it to a new thread as the user, and then we will create a new thread like that. So that's why we will be able to both drop messages and create a new thread continuously, therefore limiting our token consumption based on however many words you would like to choose here. Again, we have our wait on run function, which is going to retrieve the run and wait until it's either completed or any other action is required. In our case, complete is going to be sufficient. We initialize our OpenAI client with our key either from our environment variables, or you can insert your key here. And here again, we are either retrieving an assistant or creating a new one. Here, I want to retrieve one. Then we create an original thread. Then we enter a chat loop And we initialize the secondary memory list with its first item being assistant is you, user is me. Because we are creating a new memory structure, in this case as a list, this list will consist of several elements, which is going to have user and assistant as their role. Therefore, we want to specify to the model that assistant is going to be you and user is going to be the me, which is the user actually. Otherwise, I was having some issues, so this was helpful. Then I take user input and then create a message in this thread. When we create the message in this thread, we are using the original thread. Then we create the run, and then we wait on the run, and then we retrieve all messages, and then we also retrieve the last assistance response. As you can see, we are doing exactly the same thing in ascending order. But here in the second case, we are getting only the message after the message ID. If you remember, this was the user message with our user input. So we do have the message and its message ID goes here. And we will be retrieving the message after that, which will be the assistant response to this user query. So we are retrieving all messages and the assistance response. And then we loop through all the messages and then we append it to the secondary memory as the role and the message. Then we join all the messages in our secondary memory list and convert them into a string. And then we look at the length of it and we check for if it's more than the max words that we have specified. And while this is true, we enter memory consolidation. We set that to true. And now we keep popping messages from this list. But we don't pop the 0th element because the 0th element, as you remember, was our indication to the model that assistant is you and user is me. So this process will continue until this condition is satisfied. Then if memory consolidation, which is true, which will be true if this condition was satisfied, then we create a user memory message. We join all the secondary memory lists elements with a new line character. And then we create a new thread. And in this new thread, we create a new message based on this user memory message. So by doing this, we have both removed every previous message in the beginning, which was unnecessary, which exceeded our max words count. And we were able to restructure it using a list. And then it also had both the user and assistant roles in it, but they're not the proper roles. That's why we inserted an explanatory statement. And then when we combine them into a user memory message, now we create a new message. And then we set the memory consolidation to false. We retrieve all the messages, and then we write them to file. And then we simply display the assistance message to the user. When we run this, you can see this in action. I'm just going to say hi there. And we will be creating the messages JSON object so we can take a look. As you see, our message, our first message includes our message hi there, and the second message is hello, how can I assist you? To better demonstrate this, I'm going to set the max words to 20, or let's set it to 30, and then run it again. And I'm going to have the all messages object, which is going to get overwritten. And I'm going to say hi there. And we've received a message, how are you? And here is our message, and here is the assistant's reply. I have just asked, what is 3 plus 3? And we've received a response. And as you see now, our messages objects have changed. As a matter of fact, we now only have a single message. And the value of that message is assistant is you, user is me, remember? And the user had said, what is 3 plus 3? Assistant has said 3 plus 3 equals 6. See, this now has our redacted conversation. As you can see, the first message is hi there, and how can I assist you has been dropped effectively when we hit the 30-word limit. If I were to ask what is the capital of France, then this process will repeat again. And as you can see, we now get a new all messages object, and the user had said, what is the capital of France? And assistant answered, but this is a single message and none of our earlier messages are in there. So we have effectively limited our memory and token usage. Now let's move on to the more advanced use case. This file will be available at the $30 Patreon tier. A link will be in the description. So this one actually not only reduces the memory count, right, by removing messages, but also creates a dynamic summary of them as it goes along. But this was a bit of a mind bender, so I'll try to explain it in a diagram again. So let's take a look at this. So this is really interesting. So let's say we have our first message, the user message, which enters, and then the assistant response, and then we send another message. And then when the next one comes, we have actually filled up our max memory count. So what are we going to do? So this is going to be pushed out, and the new message is going to come in, and we are actually going to summarize this. So therefore, we will eliminate this message, but we will retain a summary of it. Okay, and then when the next message comes in, then the new message is going to enter, and the summary plus the new message is going to get summarized again. Okay, so now we have actually increase the summary with these two messages. Plus we keep track of our other messages. And this process is going to repeat, right? This one's going to be pushed out and then get summarized again. So therefore we eliminate this message, but keep a summary plus the rest of our conversation history. This was quite difficult to accomplish, but I succeeded at it, and it's it really works well. And this is we also have another option which we're going to talk about, which actually does the summarization all the time. I'm sorry, not all the time, but I think it's a more practical approach, because you see, in this situation, with each new message coming in, we will be exceeding the max memory count, and we will be performing summarization at each step. So this might not be actually, cost effective for you. And you can use GPT 3.5 to summarize. Maybe that can be an option, but this definitely probably keeps more detail. This fourth and the fifth file will be available at Patreon at the $50 level. Links will be in the description. Before continuing, I just want to mention, if you want to check out my other projects, just check out my website, echohive.live, and you can find many other projects there. Also, take a look at the Code Hive, where you can find 900 plus Python chat applications. You can just copy this code and try them out. It's codehive.app. Link will be in the description. Okay, let's go back to the code. So here again, we are initializing our client and everything. For all these projects, all we need is OpenAI library. This is the version I'm using. So we initialize max word count, memory consolidation, and then a consolidation began step. We do need the consolidation began step because in this implementation, the way I envisioned it is that we are summarizing the messages along with the summary, but we do not want to, I haven't included the summary itself in the calculation of the max word. So summary actually exists as an independent entity. So therefore, I needed a variable to keep track of that. So here I have a function that's summary GPT called, which essentially summarizes a given text. I did say always responding. Imagine we had the summary of a conversation so far. So it will summarize it, but it will actually prefix it with that, because otherwise, since we're not using the regular messaging structure of the Assistance API, then the assistant model can have difficulty understanding that this was actually the summary, but this actually solves the problem. And then other than that, we just inputted some text here, and then we get it summarized and return the summary. Again, this is just to wait on the run, and then we either load our assistant or create a new one. And then we start by creating a new thread, and then we initialize another variable which was necessary called pop summary equals false. Before continuing, let me run this script and demonstrate to you. Again, I'm going to set the max words to 30 for just to show you. Just going to say a message, hi there, and we are going to keep track of the messages. As you can see, we said hi there, and the assistant has responded. We can keep track of what's going on in the minimap. Let me zoom out a little bit. Now I'm asking what is 3 plus 3. So now we exceeded our 30-word limit. So now we have a summary which starts with, imagine we had the summary of a conversation so far. The user has greeted with hi there. So the first message has been summarized, but we also have our other messages, which were the secondary memory. Assistant said, hello, how can I assist you? User asked this, and assistant answered. And now I'm asking, what is the capital of France? And let's see what happens. Once we get an answer, this will update. Now our summary is updated. The user greeted with hi there and asked the assistant to perform a simple math problem, which the assistant correctly answered, asking if the user needed further assistance. But our secondary memory has been updated as well, with user asking what is the capital of France and assistant responding the capital of France is Paris. As you can see in this step, we continually keep track of a summary plus the conversation history by creating a new thread each time based on max words. You might find an issue with this, that it's performing a summarization at all times. So, feel free to take it for what it's worth and modify it for your use case. Like I said, the next one is actually that does the summarization for over the entire message history. So therefore, it actually doesn't have to summarize every time. We're gonna talk about that. So now that I've demonstrated this, let's talk more about the code. So when we enter the loop, we initialize a secondary memory as empty. We take in user input, and because we have created a thread, we create a new message with the user input. We simply create a run. We wait on that run. We retrieve the run steps, and then we actually save them. You can actually observe them here as well. You can run a code interpreter or anything else with this kind of implementation. Then we again retrieve the messages. Remember, we retrieve all of the messages and also the latest assistance response by using the after argument. And then we loop over all the messages which we have retrieved from the current thread, and we append them to the secondary memory. And then we check if consolidation has begun. So this consolidation happens as soon as we perform our first summarization. Because we don't want to, because this way I set it up doesn't include the summary itself against the max memory count. If we have begun the summarization process, even for the first time, then we don't want to count the first message, which is going to be the summary. So therefore, we are actually slicing the secondary memory and leaving the first message out. Then we are initializing another list called memory to be summarized. And then we perform our check against our max word. If the consolidation has not begun, if we are in the beginning of the conversation, then we compare the entire secondary memory's length, by converting into a string and counting all the words against the max words. If consolidation has begun, then we compare the messages to count against the max words. Then we do some informative printing here. And if memory consolidation, we set the memory consolidation to true, because if this process started, then we have begun memory consolidation. So we do check against the pop summary Boolean because we have two separate memories to keep track of now, right? One, the secondary memory, and another one, the content to count. And in the first run of this code, then we don't have to pop the summary because there is no summary. Then we continually pop from the secondary memory into the memory to be summarized. These are the memories that needs to be summarized. However, if we have performed a single summarization, then we will have a summary element in our list. Therefore, if we had entered memory consolidation, we are setting it to true. If that is the case, then the memory to be summarized needs to include both the summary plus the next message, right? Therefore, and since we are keeping track of the count against both the secondary memory and messages count, depending on if consolidation has begun or not, then we actually pop out of the messages count as well. So therefore, keeping both the secondary memory and the messages to count in line and in sync with them. And then we set the pop summary to false. And here, if memory consolidation has begun, then we set consolidation begun to true. That means we will always have a summary element now in our list, and pop summary, we set pop summary to true here so that we can actually perform this and not this. But at the end of it, we do set it to false. So we can check it again and again. And then because this process will create the lists of items that needs to be summarized, then we simply call the function with all those memories to be summarized. And then we get a summary of it. And then we construct this user memory message, beginning with assistant is you, user is me. And then we join all the elements of that list into a message. And then we create a new thread. And we add the summary of our memories to this thread. And then we add the user memory message to this thread. Remember, the summary is the summary of the items that are beyond the max words count. And this is the conversation history for the rest of it. Then we set memory consolidation to false. Then we retrieve all the messages. Then we save them to file and then simply display to the user the latest assistance message. I know this is quite complicated. I will actually be making a live stream about this as well, I think, because this is really interesting. And I do want to explore this memory structures more so. This was just the beginning. I hope you're enjoying this. Like I said, these files will be available at Patreon. Now let's move on to the next one, which I think is the most exciting one. Before I go on, I do want to say if you do become a Patreon, you will have access to over 180 project files, along with occasional office hours that I host almost every week. And you will also have access to Everything GPT API course, which talks everything about the new OpenAI library, the older library, region speech examples, assistance API, and I continually update this. And you will have access to the future updates as well. This Everything GPT API course is available at the $30 level Patreon. Okay, now let's talk about the final, most advanced memory management technique. Let me just run this so we can see what's happening here. I, again, have set the max word counts to 50. So as you can see, I've already started the conversation with, hi there, what is 3 plus 3, and what is the capital of France? Although I made quite a lot of typos, but here are the messages, hi there. The response from the assistant, and the next message. So this is just a regular thread so far, okay, because we haven't hit the memory limit yet. I asked it to tell me a single sentence story about AI, making quite a lot of typos. Let's see if we will hit the max word limit currently. And we have, let's take a look. See now our first messages, again, prefixed by imagine we had the summary of a conversation so far. The assistant greeted the user, answered a math question, confirming that 3 plus 3 identified Paris as the capital of France, and provide the single sentence story about AI. and we don't have any further messages. So what happened here is that we first accumulated messages until we hit our max word count, then summarized all of them. And now our max word count is going to be, our actual message count is going to be vastly reduced. And so we can actually store more messages here. And the next summarization will only occur when we hit the next max words count. I simply ask, what is 5 plus 5? Let's see what happens. And again, we got the entire conversation summarized, because the answer to that plus the summary has exceeded the 50 word count limit. But now I'm going to change it to 70 and do the same thing again. So I've added some questions such as, hi there, what is 3 plus 3, capital of France? It gave a long answer, and essentially we hit the limit of 70, and now we summarized it. And I just simply asked, what is 2 plus 2? And now what happened is that we kept our summary, but then we also kept what is 2 plus 2, and 2 plus 2 equals 4 as a response as separate thread messages, because we haven't yet hit the 70 mark yet. I hope I was able to explain this clearly, but I thought both use cases might find their uses. Therefore, I wanted to include and talk about both. So now let's talk about the code real quick. So this one is object-oriented. So we do have a class. We set our max words here. We set our assistant model and summary model. Feel free to change these. We initialize some aspects of, here's our client with the API key. This is going to take in an assistant ID if you want, or max words, right? Whatever you define here. We initialize the thread. We initialize secondary memory and the max word. And then here, create or retrieve assistant. This is exactly the same thing we talked about. It either retrieves an assistant or creates it. The next one is to create a new assistant, which is actually used over here as a method. These are all the methods we have under the ChatGPT assistant class. The next one is a send message, which essentially just adds a message to a thread as a user. Next method is our wait on run. At the end of the day, this is what we're going to be using to wait for our run to finish. And the next one is process input. This is going to create a run, wait on the run, and then when it's done, it's actually going to save to the run steps JSON file so you can observe them. And then we have update secondary memory. As you can see, we initialize our secondary memory because we want to empty it every time, and then we loop over the messages, and then we create our secondary memory as we have done in every other file as well, except for the basic chat loop. And then we check if is memory overflow. We simply just check if the length of the secondary memory actually exceeds our max words. Then we enter the consolidate memory. So we do create a copy of the secondary memory to summarize, because we do, in the case of exceeding the max word counts, we do want to summarize everything. And then we set the secondary memory to an empty list, because we will have summarized the entire conversation and we won't have anything left in our secondary memory as we did in the implementation previously. And then we simply get the summary using our summary GPT call function, which is exactly the same thing we use. And then we create a new thread, and then we send a new message, and this one is going to use the new thread. And then we have our run function, which is going to take in user input, process the input, and returns the responses, also returns the message ID. We're not currently using it. And then we get the last assistance reply, and then we update the secondary memory. And then we check if memory is in an overflow situation. If that is the case, then we consolidate memory. We retrieve all messages, and the messages to be written to file. Then we actually write it to all messages as JSON for information purposes. And then we print the last message to the user. And this is our main loop, which initializes the API key. If you want to retrieve your assistant, put it right here, and then initializes the class and just runs it. That's it. Because like I said, this was great. This test is nothing. I can actually delete that. I'll probably make a live stream about this because this is quite complex, and I don't feel like I've done great of a justice to it. But I think this is very useful. If you do think so, please give the video a thumbs up and subscribe for future content. And do let me know what you think, either here as a comment or join our Discord if you like to talk about this kind of stuff. We have over 1,000 members there who are interested in talking about this kind of stuff. Again, don't forget about the Everything GPT API course. I'll put a link in the description. If you want to find out more about my other videos, visit my website. You can perform a quick search. For example, if you're looking to learn about Assistance API, it's instant search. You can read the descriptions to videos. And if you're a patron, you can find the code download links to them. Just click on it and it'll take you there. Also, CodeHive Beta is an experiment I'm doing. I will be updating the Python applications here, but it is a quick search functionality, and you can just simply browse it. And if you do like what you see, you can actually download all the applications from Patreon shop. You don't have to become a member, but this includes all 900 plus applications there. Currently it's for $100. When I update this, I'm thinking of increasing the price. But other than that, this is all I have right now. I hope you found this useful, and I'll see you in the next video. Thank you.